Hey guys, welcome back to the video. I hope you all are doing great. And today's video is the third part of the deep learning series, the third video of the deep learning series. Now, in the first part, we learned the information, a little bit basics of how this all artificial intelligence, machine learning. Second part, we learned how deep learning works, a little bit information about how deep learning, how these things are, right? Now the third video, which the current video is, what this video is basically a little more deep, about this whole deep learning, the whole thing. So we'll be learning a little more deep in this. So today's video is the third part of the deep learning, and let's see what we're going to learn today. So without wasting more time, let's get straight into the video. So guys, now let's see what are the agenda for today's video. So we have three topics as usual. We'll be having always three topics. We'll discuss on these three topics and then we'll move on to the next, right? So today's topics, we have three topics. First topic is going to be what exactly is deep learning, right? Now in the previous video, we learned how a neuron works, what is a neuron, and from that neuron we got to know that we tried to imitate, or we tried to copy and try to make a artificial neuron. So similarly, we understood how this neuron works, and similarly to that we made our own neural network. Now the thing is, we got to know that, but the main thing is we did not exactly, from the bottom, we didn't get to know what deep learning is exactly, right? So today's video, we'll be learning the first part. First topic is going to be obviously what exactly is deep learning. Apart from that, we'll be also discussing how this deep learning works in much more deeper way. Now, if you remember in the previous video, I told about this weights, all these things. So yes, in this video, we'll be learning about all those things, all that, what these weights are, all these things, right? Apart from that, a new concept that is going to be, that is single layer perception, or you can call it as perception itself. If I'm wrong, just let me know in the comment section. I apologize for that. So but we will say it as perceptions. So we are going to just have a beginning of it. Later we are going to go in much more deeper, but this is just going to be the single layer, right? So first let's know about this beginning of how it is. So let's move ahead and see what exactly is deep learning. What exactly is deep learning is the main thing. Let's understand this with an example. So humans have seen so many, example if they have to give, they've seen dogs, cats, they can identify things, like they've seen many cars, they can identify the difference between the two. Maybe let's take the example only about these dogs and cats. They are able to identify this, right? So how will the machine identify is what is major thing, right? That's the main thing. So first, we can train the machine, what I explained it in the beginning of the video. So we are going to train the machine with many photos of, maybe let's right now currently just let's not go with the cars, okay? Let's just go with the dogs and cats right now. Now what we are going to do is, we are basically going to take the photos of these dogs and cats, and what we're going to do is, later we can give an input image, right? We can give an input image. So the photos and images of all these dogs and cats which provide is basically the you can call it as the function, or the training data, you can call it as. So later we can provide the certain image that we want to check. We are basically going to test it, right? So in input we are going to give the image, and the machine will extract the features, right, from the data we have given, from the photos of many dogs, cats, whatever we have given. it's going to extract those features, maybe like the nose, maybe the head, ears, etc., many more, etc., etc. And then it's going to predict what the object is, right? So it's going to see what the features can be extracted, and then it's going to give the predicted, or maybe the prediction what it is, basically the object is. Now if you see, similarly we did it in our stock market prediction. If you remember, we gave the data, the machine saw the features. For example, in that features we had share, promoter holding, we had the growth. So these are the features which we added. From that it did the prediction and gave us the chart, right? So that is basically what this whole thing is. So if you see now, this was the simple example what I gave, so that you people can understand how this this whole deep learning is, what exactly is deep learning, to make it easier with the example of dogs and cats, right? Now the thing is how deep learning works, right? That's the main thing. So deep learning is a form of machine learning that uses a model of computing that's very much inspired by the structure of the brain or the brain cell. It is called as neuron or the neuron cell. So if you see, this is the information which I spoke in the previous video also. It is the basically the copy of it, or the main trying to imitate or replicate how it was. This is the main focus of it. That's the main thing. So trying to do the same, how making the model is basically what the main idea is, how this deep learning works, what I explained in the previous video. So that is basically what I'm trying to tell right here. From the neuron which we have, or the cell which we have, from that we are trying to make another artificial neuron. Now let's move ahead and let's see few examples. Let's understand why we need an artificial neuron. That's the main thing, right? Now that's what we're mainly focusing on. And yeah, as we told, we're going to talk about cars later on. Now we have the cars. We have the Mahindra, Tata, we have Tesla, we have Suzuki, and we have Ford. So these are the cars which we have brought. Now for example, as I have we have XUV, we have Tata cars, we have Swift, we have Model S, 3X, and we have Ford, right? And I want to classify the type of cars on the basis of this data set, right? Or I want to classify from these from in the form of the data set. So I have two options. One, either I can do manually, or two, what I can do is train the machine. Now if you see, manually I can just tell the machine that this is basically the car of Mahindra, this is basically the car of Tesla, this is basically the car of Ford. So I have that manual option, but this can't be every time something that is always which we can do. At one point we can't do manual, we have to be automated, we have to be where the AI is controlling it. Now if you think about the metaverse itself, what I spoke about in the first video, where we have the blockchain itself, where data is so huge that you can't do it always in manual way. The person who's logging in, logging out, all these data you can't put it manual. You need to put it in kind of like a whole automated way. So in order to do that, you need to train it, right? So that is basically. So again, we obviously use the machine, right? Because it is much more easier than the human brain to put the input. So this is why the whole how understanding the neuron works, the artificial neuron works. Now we are going to see how the perceptron training or the algorithm is done. right? Now we took the example of the cars. Now we'll be learning how this training is done, how this perception is going to be used. So how the algorithm is trained, or how learning how the algorithm works, all these things. So if you see, we have an example right here. We have, now this is the one, I'll just bring my mouse right here. Yeah, so this is the same image which we had the previous, if you remember, the second part we had the same image, but it has different right here. If you see, these are the X, these are the inputs, and the one which I was talking in the previous video, the weights, is basically these are the weights. These are the weights which I was talking about. Now don't worry, I'll be explaining that. This is again the transfer function, basically the function where it's going to be structured, where it's going to be, where the training is going to happen, all these things. Maybe you can call it the nucleus of the whole artificial neuron. And then we have the output, the transfer function, that is going to be the axon terminal which we made artificial, and then the outputs, right? So let's see the step by step. Let's understand how this whole thing works, right? So first we are going to initialize the weights and the thresholds according to it. So we have W1, it could be W1 again, W1 2, we can put it as till nth number, like Wn, till the whole, wherever we want to go to. So we are going to initialize the weights and thresholds. Now after this, what you're going to do is you're going to provide the input, and the input is going to be calculated. Now how it's going to be calculated, we're going to talk about that also. So these are the whole inputs, these whole things are the inputs. You're going to give it with the weights, everything which you have assigned, and then it's going to go to the calculation part, right? So here in the transfer function, it's going to be calculated again the same formula, sigma xi and wi. Basically it's going to be added, and then the transfer function. Now the transfer function, if we talk about that dogs and cats, what the idea is, now this wi, let's assume this, okay, for you to make it easier, I'll tell you this. So these wi, w1, w2, or w1 or wn, what you can call it as, are basically the nose, ears, size, maybe what else we mentioned, head, etc, etc. These are the weights, okay, those are the weights. And x1, x2 till xn is basically the input. Maybe it could be could be an image of a dog, could be an image of a cat, could be an image of some other animal you can mention, maybe lion. Let's just mention it right now, okay? So this is the all the images, we give it input. Now with the weights, what is going to happen in the transfer function, it's going to check, are the ears matching with the image, are the noses matching with the image, are everything matching according to the whole image what we have given right here. Once all these things are done, it's going to give the output. The calculation is done, output is given. If the output is done, if we have got the output, then it's good to go. There's no other change. But if we don't get the desired output, the weights are going to change by itself, or we are going to change it. Anything manual, or it could be changed by itself. The weights are going to be changed. They update the weights. Okay, we can call it the updation of the weights. So again, once the weights are updated, maybe the ears did not go well, maybe the nose did not go well, we are going to update it, and then anyways you have provided the input. So we are going to check according to that. After it checks, it goes to transfer function, all those things, the axon terminal which we have created artificial one, and then it's going to give the output. Again, if it does not go, again the same procedure. So this procedure is going to repeat again of step 2, step 3, again and again. It's going to repeat again and again, until we don't get the desired output. So it's going to repeat again if it does not get the proper output. So that's the whole concept of this whole artificial neuron which we have created. Okay, so I hope you got the idea of this perception learning of this algorithm, how this whole artificial neuron works, how the algorithm works, right? Now let's move ahead and see few activation function. Yeah, in the single layer itself we have activation function. Now the activation function, we've told about the transfer function. After the transfer function, the axon terminal which I was talking about, that is basically the activation function basically. So we have many other activation there. We have very different activation function. One of them we have the step function, and we have the sine function, one more we have the sigmoid function. So these are some of the activation function which are going to be used in this whole procedure to activate and to check if we get the desired output. If not, again it's going to be activated, again the weights are going to be changed, again the whole procedure is going to repeat and again until you get the proper desired output. So this was basically about this whole activation function. This is the diagrams of the activation function. We have the x coordinate, y coordinate. From that I've put the whole thing. So this is basically a little bit about activation function, and that brings us to the end of the third part of this series, the third part of deep learning series. I hope you understood this video. This video was quite simple, not much of that difficult than the part 2. I am sure part 2 was little not that to the it was not that much easy, but I hope you understood that. Part 3 was just like a bridge connecting part 2 and part 3, basically a combination of it. There's not much of it, so you will have a better idea of it. So I hope you liked the video. I hope you understood. I make sure that it was the simpler and best so that you can understand. So make sure to like the video if you did, and subscribe the channel if you have forgotten or if you have not done. To people who have already done, thank you so much. And if you have your friends or anyone who are interested in deep learning and machine learning or neural network, make sure to share it to them and let them also know that we are having a deep learning series. So that's it for today's video, guys. I hope you liked it. Till then, make sure you watch the complete videos from the beginning and you've done all the things. So till then, happy coding. Have a great day. Take care and peace out. Bye.